Lesson 5, number 7. Write the equation of the parabola that has the shape of graph f of x equals 3x squared, but with the point -5 and -2 as the vertex. The vertex of a parabola is known as hk. And the vertex form of a parabola is y equals a x minus h squared plus k. So plug the vertex into the formula y equals 3x squared, which gives you y equals 3 x minus -5 squared minus 2, which turns into y equals 3 x plus 5 squared minus 2. Lesson 5, number 17. Solve the equation x squared minus 3x equals 18. Subtract 18 to the other side and set your equation equal to 0. Doing that, you get x squared minus 3x minus 18 equals 0. Then factor, which gives you x minus 6 and x plus 3. Set your factors equal to 0, and then set those equal to x, giving you x equals 6 and x equals -3, giving you the answer 6 and -3.
Lesson 3, number 7. Determine if this is or is not a polynomial function, and if it is, identify the degree. F of x equals x squared plus 3 divided by x to the 6th power. Note that f of x actually equals out to x to the -4th power plus 3x to the -6th power. Due to the exponents not being all negative, it is not a polynomial function.
Lesson 7, number 7. Graph the given function by making a table of coordinates. F of x equals 5 to the x. 5 is the base with x as any real number. The base is a positive constant. To complete the table of coordinates, plug in a real number for x into the function. You can do this in a calculator or you can do it in your head. To graph the exponential function, plot the points and connect them with a continuous curve. The graph approaches but never touches the negative portion of the x-axis. Therefore, the horizontal asymptote is y equals 0. The range is 0 to infinity, while the domain is -infinity to positive infinity.
Lesson 3, number 9. Use the leading coefficient test to determine the end behavior of the graph of the given polynomial function. F of x equals 8x to the 5th plus 7x squared minus 5x plus 9. The highest exponent is 5, so we're going to be focused on that variable. The leading coefficient is 8, the degree is 5. Because the leading coefficient is positive, the graph rises to the right, and the degree is 5, which is odd. An odd degree causes it to go in the opposite direction, so the function falls to the left. The graph of f of x falls to the left and rises to the right. Lesson 3, number 11. Find the zeros for the following polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. F of x equals 9, x plus 5, x minus 2 cubed. The two factors are x plus 5 and x minus 2, so you're going to set each equal to 0 to find the zeros. So your zeros end up being -5 and 2. The multiplicity is 1 for the 0, -5 because it only occurs once, and the multiplicity is 3 for the 0, 2 because it's cubed in the original function. And both zeros are going to just cross the x-axis because each multiplicity is odd.